Hello there. Welcome to my YouTube channel. Today I will take you through heat conduction through a composite wall and heat transfer. Let's tackle this question. An exterior wall of a house may be approximated by a 0.1 meter layer of common brick of thermal conductivity K equals 0.7 watts per meter per degree Celsius, followed by a 0.04 meter layer of gypsum plaster of thermal conductivity K equals 0.48 watts per meter per degree Celsius. What thickness of loosely packed rock wool insulation of thermal conductivity K equals 0.065 watts per meter per degree Celsius should be added to reduce the heat loss or gain through the wall by 80%? Solution. Here is a diagrammatic view. Given. Thickness of common brick LA equals 0.1 meters. Thickness of gypsum plaster LB equals 0.04 meters. Thickness of rock wool LC equals X meters. Thermal conductivity of common brick Ka equals 0.7 watts per meter per degree Celsius. Thermal conductivity of gypsum plastered Kb equals 0.48 watts per meter per degree Celsius. Thermal conductivity of rock wool Kc equals 0.065 watts per meter per degree Celsius. Finding the thickness of the loosely rock wool insulation. When rock wool insulation is not used? When rock wool insulation is used? Equating and taking into account efficiency. X equals 58.8 millimeters.